Hello, the internet, and welcome to Open Source Directions, hosted by Quansight, the webinar that brings you all of the news about the future of your favorite open source projects. My name is Anthony Skopats, your host for Open Source Directions today, and co-hosting with me is Madikan.
Hi, I'm Madikan, and I'm really excited to be co-hosting today with you, Anthony. I am a postdoc at the University of Illinois at Urbana-Champaign, and I work on a project called YT.
Hi, I'm Kiran Kate. I'm very happy to be here today. I work at IBM Research in New York, and I'm a core developer of Lale. I have a background in applied machine learning.
Hello, I'm Martin Hürzel. I'm also at IBM. I'm a researcher here, and my background really is in programming languages, but these days I'm working full-time on Lale.
Excellent. Well, it's really great to have both of you here today, and we're really excited to learn about Lale. But before we do that, we're going to have our personalization section. So this week we have our famous tweet of the week section where each of our panelists here gets to share a tweet that they've been enjoying recently. So Martin, I believe you're first up today.
Right, so I'm sharing a tweet from Archive about a paper on automatic machine learning by pipeline synthesis using model-based reinforcement learning and a grammar. So Lale is about AutoML, and this is a paper by people at NYU on AutoML that I found particularly exciting because they're looking at grammars, and in Lale we are starting to look at grammars as well.
Awesome.
Okay, I believe it's mine.
Yep.
Yeah. So I really appreciate LaTeX. With due respect, here is a tweet from Mark Riddle, who is an associate professor at Georgia Tech. The tweet goes is that I removed a sentence from our 6-page paper being written in LaTeX, so now it is 6.5 pages.
Beautiful. It truly is a tool to be appreciated. Yeah. Okay, so my tweet is from Anne Bonner, I think is how you pronounce their name. And this person was working on basics of NumPy sort of tutorial that was merged into the docs this week. And so this tweet is the person announcing that it was merged. And I encourage all of you to click on the link in the tweet that goes to the NumPy dev docs that has this tutorial. It has such clear explanations, and I think we should all aspire to have docs that are this clear for beginners.
Here, yeah, and I know the NumPy docs have really gotten a lot of work recently. So thanks to CZI and the Google Google Doc Sprint thing for that.
Mm-hmm. Yeah.
For my tweet, there is a really beautiful thread about recreating a few of Maxwell's original figures in Matplotlib, and you should go check it out. It's a great thread, a lot of really cool responses. Colin Carroll's, I think, were some of my favorites. He's got a repo up. There's some others that are really good. So please go check out that. And with that, we're going to get into our discussion of IBM Lale, which is a library for semi-automated data science. And we have a few questions here. We're just going to go back and forth and get to learn a little bit about the project to start off with. So.
Yeah, okay. So my first question for both of you is, why was this project started and what need does it fill?
So this project was started to unify a whole bunch of different AutoML research projects. And so the thought was that if we had a common unifying abstraction or a language or something like that, as a common backbone across all of these, then we would be much more effective. Now it's really much more outward facing and of course open source. And so really the goal is, the need that it fills is to make it easier to use AutoML and to automatically search pipelines and construct them.
Excellent. And what is the history of the name and the logo and where does this come from?
So it started out as an acronym, but then it immediately became obsolete. So I'll just tell you the other part of the name, which is there's this tradition in programming languages to name languages after something beautiful, like Ruby or Perl or Java. I don't know if Python is in that. Yes. So it turns out Lale is actually the Turkish word for tulip. And why Turkish? Well, because that's where tulips are originally from.
Oh, okay, cool. And I really like your logo of the hand-drawn tulips. It's very sweet. Yeah.
Thank you. I'll tell my daughter.
Oh, okay. Oh, so now we know the origin of the artist too. So yes. Are there any alternative projects out there?
So Lale has a lot of features. I wouldn't say there is a single alternative that I can quote, but there are closest projects such as Hyperopt scikit-learn, Auto scikit-learn, Auto Vecca, Tpod, GridSearchCV, and Randomized Search CV from scikit-learn, and so on. Since I mentioned scikit-learn, I think I would also like to mention that Lale is not an alternative to scikit-learn, but it's built on top of scikit-learn. So as the demo and the roadmap will show, we use a lot of features and operators from scikit-learn. From the other tools I mentioned, we definitely take inspirations, but our attempt has been to be more general and flexible.
Right. So it's more about being a grammar on top of those things, these other tools. So what technologies is Lale built upon?
So in addition to scikit-learn, which Kieran already mentioned, one technology that might surprise you is it's also built on JSON Schema. So JSON Schema is basically a type specification language for JSON documents that turns out to be extremely useful for AutoML, because in AutoML, you want to specify the types of your hyperparameters, and then you want to search just inside of those types. And so that turned out to be useful both for automated search, but in addition also, of course, for what it's intended for, which is type checking. And then, obviously, it's based on Python, and we actually make quite a bit of use of GraphViz, among other dependencies.
Awesome. Yeah. Can you tell me who started it? Is it the two of you or a lot more people?
So initially, for a few months, I did some kind of early experiments trying to find out various different abstractions for AI automation and machine learning automation, and went down some wrong paths. And one of the good things is I have a lot of smart colleagues here, and including Kieran, who brought me back from the brink more than once. And so eventually, when we settled on the scikit-learn conventions and making it very compatible with scikit-learn, that's when Kieran and a few other people here joined the project.
Well, that's a segue if I've ever heard one. So who maintains Lale?
It's born out of we maintain it so far, but now that it's open source, we hope that more people would contribute, and at one point, maintenance will be a core contribution from outside.
So, okay, so that's really interesting because you said it's now open source. So where do you see your users and contributors primarily coming from? What communities are they coming from? Are they mostly from one place or another?
Right, so it's really built for data scientists, and specifically for data scientists who like Python and who like scikit-learn. I guess that subsets it a little bit because while we support, for instance, deep learning, that's not yet really our focus. And also, while we have some support for R and Java, again, that's more as a kind of proof of concept, but we haven't really dug deeper into that so far.
Yeah, that's really interesting. So is Lale participating in any diversity and inclusion efforts, or is this part of, since it's coming out of IBM, or yeah, what's the story there?
So Lale in particular, I would say the short answer is no. But since we're part of IBM, we have access to a lot of diversity initiatives that IBM takes upon, which is, some of them being women in data science, women in machine learning. So it makes sense for us to reach out to them. We haven't done that yet.
Right. Well, great. And I think at this point, let's dive in and see some Lale. So I think you have a demo to share with us.
All right, let me make sure that I can actually do that. Now comes the technology, right?
Yeah. It's always the fun bit here where screen sharing and everything. And I believe there's a notebook that Brandon will be sharing in the chat here very briefly.
So let's hope I'm actually sharing yes, this is the one. Okay.
First rule of live demos. No, we'll get this. So.
Can you see my screen?
Yep. Perfect.
Oh, excellent. Great.
Beautiful.
Right. So this is a Jupyter notebook, and as any data science project, also for this demo, I want to start from the data set. And so I selected a data set that really comes from OpenML, and it's called the credit G data set. And now, if you look at this pandas visualization of 5 of the example rows, you'll see that the labels Y, they happen to be just zeros and ones. So it's a binary classification data set. And then there's a total of 20 features. And I selected this data set because it's a mix of numerical features, such as duration or credit amount, or there are going to be more numeric features in here, and categorical features. Now, the categorical features are things like saving status, where there are only a few valid values that you can have for saving status in a column. And so as a data scientist, if you want to build a pipeline for this, you might already have some ideas of what kind of feature preprocessing might work for numbers or what might work for the numerical columns. But if you're like me, then you don't really want to make all those decisions by hand. And in particular, you also don't really want to, you're going to experiment with different classifiers in the end, because for this binary classification, there could be different choices. And so I'm going to start by importing a whole bunch of operators that might be useful for this task. And you'll see that many of them I'm just importing directly from scikit-learn. So a normalizer, a one-hot encoder, logistic regression, a support vector machine, and so on. I'm also importing an XGBoost operator. And then there are a few Lale-specific operators. So projection is really, it helps you pick a subset of the columns by type. So for instance, you might project just the numeric columns. Concat features is essentially horizontal stacking. So this is what we use to bring pre-processing paths back together. And then it turns out we also have a no-op, which just passes the data through unmodified. And that's useful to make some operators optional inside of a pipeline. So I don't know why this is taking a little bit longer than usual. I think maybe the webinar is chewing up some of my CPU here.
Yeah, for sure, probably.
But I guess I should point out this wrap imported operators at the end. Basically, what it does is for all these scikit-learn and XGBoost and various other operators, it attaches metadata that then becomes useful for hyperparameter tuning. Now, this next cell, that's where really the scikit-learn compatibility comes in. So make pipeline and make union, those are really scikit-learn functions. Make pipeline is sequential composition. Make union is kind of side-by-side composition. So if I describe this inside out, then this inner pipeline here, it basically selects the numerical columns from the data set, and then it either normalizes them or not. So this vertical bar is our choice combinator. And as a data scientist, I might not know whether it's useful to normalize or not. So I'll just leave that decision to AutoML instead. For the string columns, I already know that all of these are categorical, so I decided to just pipe them directly into a one-hot encoder. And then what this make union does is it brings together the pre-processing paths. And so the outer make pipeline basically takes all of this pre-processing and pipes it into a choice of 3 different estimators. And so if I look at this visualization down here, you'll see the first pre-processing path, which projects just the numbers, and then it does a normalizer or a no-op. The second pre-processing path, which projects just the strings, and then it does a one-hot encoder. You concatenate that together, and then you have a choice of 3 possible binary classifiers.
Yeah, that's a really neat visualization, especially with the hover text and everything that tells you some extra metadata.
Yeah, it turns out the sugar on top is actually more important than one might think.
Oh, absolutely. Being able to visualize these pipelines is extraordinarily useful.
Yeah, and it looks like that's coming from your Lale helpers, right? So this seems like it would be very nice to use for anybody.
Right. So exactly. And then I guess another thing I should point out here is that in terms of AI or machine learning automation, the automation will have to do multiple things. One is it has to make these decisions of which operator to use. normalizer or no-op, or one of these three, logistic regression, support vector machine, or XGBoost. But then it also has to do hyperparameter tuning for any operators where we haven't specified the hyperparameters. So for instance, XGBoost, I didn't specify the hyperparameters. So if a AutoML decides to use it, it also has to tune those hyperparameters for us.
Right.
So actually, let me just quickly kick this off, because that is supposed to actually take a little bit of time. So Hyperopt is a popular AutoML open source library, not written by us, but we are using it as one of the backends for Lale. Other backends include GridSearch and SMAC, which is actually the backbone of scikit-learn also.
Right.
And so what this auto-configure call does, actually, I should scroll up a little bit to give you the context. So the pipeline we created up here, we called it the plant pipeline. And then we can do plant pipeline.autoconfigure, providing the training data and the optimizer. And then we are basically saying, OK, let's do this with threefold cross-validation. And let's just try only 10 different possible pipeline shapes and hyperparameters in this space. And so that's what's executing down here. And so what Hyperopt really does is it's a Bayesian optimizer. It has its own search space format, and when we use it inside of Lale, then we have to translate from these JSON schemas and from our pipeline specification to the specification format of Hyperopt, which of course looks quite a bit different. And so one of the values that Lale provides here is it gives you a syntax that's much closer to scikit-learn and much leaner. And it then bridges the gap between that syntax and a tool like Hyperopt or the other backends that I mentioned.
So the question here is, if I wanted to write in JSON this planned pipeline, would I be able to do that and then load it in, or is that not? That's where it comes from. That's where the JSON schema parts come, or the grammar of the pipelines.
The answer, there are two answers to that question. The first answer is yes, you can represent pipelines themselves as JSON.
Okay.
And we have a schema for them, and we can export and import to and from JSON.
Perfect.
The other answer, though, is that for each of these operators, we actually have a JSON that specifies the hyperparameters just of that operator. So, for instance, it's a random forest variant. And so one of the things that you can specify in XGBoost is the maximum number of trees that it is supposed to consider. And then various other things like how big does each leaf have to be, and how deep can the trees be, and all of that. And so so when Hyperopt searches over the search space, of course, it's going to need to know, well, what are the hyperparameters, what are their types, and what is the range that is reasonable to search over. For instance, for the number of trees, if you didn't put an upper bound, then maybe Hyperopt might attempt 4 billion trees, because, well, that's a reasonable number, right? And then it would just bring the machine to its knees and not really produce any reasonable model at the end.
Right. Yeah.
All right. So maybe while we are waiting for this to finish, I'm going to briefly show one more thing in the visualization, which is that as you can see, for most of the operators, we did not specify hyperparameters, but actually for the support vector machine, we specified one of them, which is to disable the dual formulation. And so this is why the tagline is semi-automated data science. So it allows you to automate what you want to, but if you're a control freak, or if you're a data scientist who really knows what you're doing in some parts of your pipeline, then you can hardwire some of the other hyperparameters and only leave it to Hyperopt to search the others. And I guess one more brief thing to mention is that each of these nodes actually happens to be a URL to the documentation of that operator. So as you can
that's really helpful.
That's so nice.
So talking about hyperparameters, this is the dual formulation hyperparameter, for instance.
Right.
Okay.
Yeah.
All
I
right.
feel like now a lot of projects have more work to do because I just saw that. That's cool. That's really cool.
All right. So I think maybe in the interest of time, let me just switch briefly to an offline version of this notebook, which actually anyone attending this webinar can also look at. So this is the Lale open source page, the GitHub repository, github.com/IBM/Lale. And if you go to examples and to this last talk with today's date, that's the notebook we are looking at right now. And so while we are waiting for that to complete, we can see that once it is completed, really at the end of Hyperopt, you just know that it ran 10 trials and that each trial took about 7 seconds to run, well, without other load on the GPU. Now, what you can do is you can use this trained pipeline just as you would use any other scikit-learn pipeline. And so, of course, one of the most popular things to do with the scikit-learn pipeline is to actually make predictions on that. And so during training, of course,
Oh, well.
Oh no.
There we go. I think a brief interruption of our demo here.
Oh no.
I can try to bring up that page or as well.
Yeah.
Or Kieran can. So let me see.
Yeah, let me try to.
Let me get a new thing here.
Okay, well, while that's loading, I also want to give a shout out to all of you because I was looking through your docs and I really love the diagram you created for contributors to show the process of creating a pull request and contributing. It's kind of similar to the diagram we saw before.
Sorry.
And it's very cool.
Oh, all right. Kieran's got it back.
Thank you.
So.
Is that, oh, I think Martin is trying that as well. So maybe I should stop sharing.
No, you can keep sharing, I think, because I think he's not back in yet. Oh, there we are.
Here we are. Hi, Martin.
I'm back. I don't know if I'm still sharing.
You are not.
No, you're not.
Okay.
Do you want me to share the same notebook, Martin?
Yeah, maybe, if you don't mind.
Okay. Yeah, sure.
Actually, hold on. I guess
So-
yeah.
Do you see that?
Yes, we see that. That's, yep. So feel free to go into it. Yeah, this next part down here. So
I don't know if Martin wants to continue.
Oh.
Actually, Kieran, if you can hear me, maybe you should continue because I'm still having connection problems here.
Okay, so right, I think we were at this cell where we are saying that from the output of auto-configure is a configured trained pipeline that was trained on the data set that we gave as input. And just like scikit-learn fit and predict, we can call a predict here on the trained pipeline to get our predictions. The accuracy happens to be 72.1% for the 10 trials we did. And we can visualize it using GraphViz again. This is another API that Martin recently implemented. The other way of visualizing a pipeline is that we are able to print it into Python code.
Oh,
so if someone wants to recreate this pipeline, this is the code that they can use and recreate the pipeline. So one difference compared to how it was created earlier here is we used make pipeline when it was created, which is a scikit compatible syntax. But Lale also has operators which is really an easier way to create a pipeline. So the right shift operator here is equivalent to make pipeline.
Oh,
the ampersand is equivalent to make union and so on. So essentially we are saying that there was a project and a normalizer and another. So along with that, there was another project and one hot encoder, and both of them get into concat features, the final matrix that's passed on to linear SVC for classification. So
wow, that's
I think that's all we have for the demo. And there is, this part we will discuss during the roadmap, the bottom part.
Okay.
Okay, perfect. Yeah, it seems really impressive. When you have that that particular syntax with the left shifts and ampersands and everything, are you able to?
Sorry.
Are you able to also pass in parameters like above where you had the dual equals false? Is that something that you can do right here in the working?
So here, if you notice, yeah, so linear SVC is an object that was created.
Oh, I see. Yeah, so it's not just.
And it has a dual equal to false. So in the trained pipeline that Hyperopt returned, we had linear SVC with some parameters chosen already for us.
Right.
By Hyperopt, the search that happened during the automation. So it chose a value of C, which was the best for those 10 trials.
Mm-hmm.
Dual was false, which we gave as input. That was a restriction that as a constraint we had provided.
Right.
And tolerance for stopping the criteria was this.
Yeah, so this really does let you kind of mix and match pieces, pre-trained pieces or pre-optimized pieces and new clean parts of the pipeline and then re-optimize over them. That's very, very nice.
Yeah.
So I think at this point we actually are ready for our roadmap discussion, which is kind of the center part of these episodes here. And so just to remind everyone, these are places where Lale is looking or seeking contributions, either in terms of code or funding or people just participating in the project. And so, and these are the directions that the project is going. So these are all things that Lale would like to see happen in the foreseeable future here. So, and I know that you both have written a bunch of roadmap items here. So if we can just start to dive in and talk about some of them. So.
Yeah, so before we get into individual items and the details, this is what we would discuss. And these are high-level items. We have smaller items on the roadmap like improving documentation and so on.
Mm-hmm.
But let's get into each of those one by one. So general improvements, we have about 144 operators from scikit-learn today, some from PyTorch, TensorFlow, Weka, R. But I think it's always good to have more and more operators to support more use cases. So we would really like contributions along those directions. There is a very well-written guide here to add new operators. And for any of these, if there are, we can always reach out. You can always reach out for more help. When I say more AutoML tools, like Martin showed in the demo, Hyperopt is one of the optimizers we support. We support GridSearchCV and SMAC so far. But there are others on our list like Hyperband and RBF Opt. And there are more AutoML tools which could be added to make this richer. We do not have a well-written guide for this, but overall, there are two phases to support a new AutoML tool. The first one, which we call a schema simplifier, we believe it's very general and it can be reused. But the second step is really specific to that particular tool, where we'll have to take into account the search space specification for that tool and how to compile it into what it needs.
So for those backends, you are using other tools out there and other libraries out there. You're not rewriting those algorithms in Lale. Is that correct?
That's right.
Yeah.
Yes.
And you said,
some of these. Oh, sorry. Go ahead.
And you said if somebody wants to help implement that, they should reach out. Where would be the best place to reach out? Would you want that on GitHub, or do you have a mailing list or something that you would prefer?
On GitHub.
Okay.
Is the best.
Or you
I believe Martin would share. Sorry, go ahead, Martin.
Or you can also contact us directly. So, especially on this backend side, our colleague Avi Shinar, he's the one who has been in charge of the first few backends, and so he will be the right person to work with on the next N+1 backend.
Great.
And he's already working on some.
Exactly.
That's exciting. Yeah.
Yeah. So Martin, do you want to share
Right. So let
The
me
dataset schemas.
talk a little bit about dataset schemas. So I sound like a broken record because I keep mentioning schemas. So the main use of schemas in Lale is for hyperparameters, as discussed before. So, for instance, that the dual formulation can be true or false, and that is something that a backend needs to know in order to actually search a good value for that hyperparameter. Now, dataset schemas is something very different. This is the schema for the actual data that is being processed by the pipeline. Which often is tabular, but actually we've also experimented with all kinds of other modalities such as time series data, images, textual data, etc. And so having schemas for those can be quite useful because often which operator is even applicable for a data set at a particular point in the pipeline really depends on what's in that data set. So, for instance, our dataset schemas might indicate that a column still has missing values, and then you might want to do an imputation before you pipe it into something that cannot handle missing values. So this is a kind of an ongoing feature. We do now do pretty pervasive dataset schema checking, but at this point it also can lead to a lot of error messages, and so we're actively working on making that experience smoother and more friendly.
Yeah, that seems like it's a subset of a lot of or it's a very difficult part of sort of classification of what data actually is, right? And typing your data and knowing that ahead of time can be very difficult. So
yeah,
I see how that's.
And actually, I wanted to shout out, since I noticed that there's somebody from Darmstadt in the webinar. We actually had a summer intern from Darmstadt, Andrew, who really helped us with this dataset schema business and sub-schema checking and all of that.
Well, yeah. Hopefully, maybe you two can meet up at some point. That seems like it might be a fun interaction there. Yeah. So, are there other? Yeah. So continue, Martin, on past the dataset schemas. You know, there's other points here.
Yeah, I think maybe Kieran, you want to talk about text data?
Yes. So the item reads support for text data. Can you see the notebook that I'm sharing?
No, we can just see your PowerPoint.
Oh, okay. Okay. So I have to start sharing the notebook.
Yep.
Can you share it now? I mean, can you see it now?
Yeah.
Yep.
Okay. So this is an effort to expand the scope of Lale to from tabular data, which we call structured data, to other modalities. And text is high on our roadmap. It's very common for a data set to have a combination of text and categorical and numeric columns. And that's something we want to support, but we also, so an internal version of Lale supports text pipelines by themselves, just text data as input and text classification as a task to start with. We're also looking at other tasks under NLP, but this example is to show what is already working. And this, in fact, the notebook is there in the open source version. So let's say we have a data set. In this case, it happens to be drugs.com dataset from UCI. It has a few categorical and numeric columns, but there is a text column, which is a review of the drug. And the task is to predict the rating, like patient satisfaction rating. So for this data set, I'm going to quickly show one pipeline. I mean, there are other pipelines in the notebook, but this is what a slightly more complete pipeline would look like. Is you want to be able to project. So this is similar to what Martin showed earlier, project a few columns or a type of columns. In this case, I'm projecting a review. I mean, the review text, and passing it on to two text vectorizers. So the job of these would be to take text data as input and create vectors of numbers, like floating point vectors, as output. So BERT is an embedding It's a pre-trained embedding, and we are using the PyTorch implementation. TF-IDF vectorizer comes from scikit-learn. So we are saying it's a choice between BERT and TF-IDF, and for review, we don't know which embeddings will perform better. For numeric columns, we want to be able to take them as is, I mean, in this pipeline at least, and concatenate the two types of features and use some regression model at the end. So this pipeline is simple, but the objective is to show how it would work together for multiple modalities. And in that context, we are adding many NLP operators so that we could use them here. Like I said, an internal version of Lale has other NLP operators as well. And in general, I think the objective would be to add more features to support the use case.
Can you tell me if the colors on the graphes are meaningful, or is it only to add contrast?
No, it's a good question. In fact,
Maybe you want me to jump
so
in?
this is what is one of the features. Sorry?
So the color indicates how much still has to be decided. So white indicates it's already trained. So you don't even have to train to learn the coefficients anymore. Everything has been decided. And then light blue means, well, it's not trained yet, but at least we have specified all the hyperparameters. So we don't need to run HPO anymore to figure those out. And then dark blue means, well, it's you can't even train it yet, because in order to train it, you would have to configure the hyperparameters, and you might also have to make some choices between different operators.
That's so nice to give you an intuition of like where things are at in your pipeline.
Yeah, that's very, very useful.
Yeah, that's super cool.
Yeah. It's one of the features that we call as life cycle as bindings. So these are different life cycle stages of a pipeline, and we have names for each of those. So I'm going to go into the next roadmap item, which is support for higher order operators. And again, we'll share a notebook. So
Sounds great.
Sorry.
You have a great series of notebooks. I mean, they're in your repository. I encourage everybody who's interested to go look at them because they're very explanatory, I feel.
Yeah, this one is not in the repository because it's showing just one operator example, but I think, I mean, you have examples of these operators in our test cases and so on.
This is an exclusive demo. Exclusive to the,
yes.
to the webinar.
Just for you.
So the use case, I'm showing an example of a higher order operator, and I mean, it's not a new concept as such. Scikit-learn has some, they call it meta estimators, and we have other operators as well. But I want to talk about the optimization piece a bit later, so I'm giving an example to set the context. So let's say we have a pipeline, and again, a simple pipeline which consists of min-max scalar and MLP. And we want to run this, I mean, train using this pipeline on a data set that does not fit in memory. And I'm using a simple data set or a small data set, but if we had a data set which does not fit in the memory, so scikit-learn has support for something called as partial fit, which is to support this use case. And the idea is that instead of fitting a pipeline on the entire data set, you can fit it batch-wise, so partial data at a time. And so Lale has an operator to support that, which is called batching. Batching as an operator would take a nested pipeline. So it takes an argument, which is an operator, can be a pipeline. And in this case, if you notice, the earlier auto-configure example we saw with Hyperopt, as of now, wouldn't search over min-max scalar and MLP classifier hyperparameters. Because the outer pipeline is only one node, and it has its own hyperparameters like batch size. But ideally, we would like to also be able to perform algorithm selection and hyperparameter tuning on the inner pipeline. And the item, I mean, the roadmap item is really to support this seamlessly. I mean, using the same API, the same schemas, but allowing selection of the inner pipeline as well. And like I said, batching is not the only operator. There we have boosting, bagging. We also have some backpropagation support for text. So all of these will fall under this category.
All right, let me try if I can share the screen again.
We trust you.
Yeah, just as a reminder, again, these are all places where Lale is looking for contributions or collaborations or potentially funding for more open source work.
Mm-hmm. Yeah. And all these seem like such impactful sort of areas for your project. So it seems like a potential contributor or somebody who wants to help out, this would like really help the package a lot.
Yeah, and out of curiosity, how big is the code base and how is it structured and kind of where would people jump in just while we're waiting for more?
Actually, wait a second. So Kiran, do you mind sharing your screen again with that notebook from earlier? Sorry.
Oh, that's fine.
Sure.
So the size, I haven't counted lines of code recently, but I guess, so one big part of the code base is supported operators. There are, by last count, 144 operators. Many of them are estimators, so classifiers, regression, and so on. But there are also a whole bunch of transformers, things like GFIDF or normalization or PCA and so on. So that's one big part of the code base. Another big part of the code base, of course, is just kind of the framework of how do you put together operators in a pipeline with these combinators and graphics and JSON conversion and all of that. And then another big part of the code base really is backends, so supporting Hyperopt, supporting GridSearch.
Right.
Hopefully more in the future. SMAC.
Yeah.
All right, thank you for sharing on my behalf, Kiran. So what the examples that we've shown so far, they showcase two kinds of automation. One is hyperparameter tuning, and the second is operator selection. But what if you don't even want to specify strictly what shape your pipeline has up to operator selection? And so one way to do that is by specifying a grammar for possible pipelines that users might want to try out. And so this is an example of that. And this is, I mean, there are 2 or 3 very recent papers that do reinforcement learning or evolutionary algorithms to find pipeline shapes. We aren't there yet, but we have focused on kind of the Python syntax for grammars. And so what you can see here is basically a grammar that allows you to specify a pipeline of any number of transformers followed by a single classifier. And the way you do that is by saying, well, the start symbol says make pipeline with some recursive transformers non-terminal, followed by just a single estimator. And if you look at primitive estimator, you'll see it's just the 3 that we saw before. But then this recursive transformers can be either a no-op, meaning that's the base case of recursion, just stop generating more transformers, or it could be a pipeline of recursively even more transformers followed by a single additional transformer. So if you keep unrolling that, you get one more transformer each time you unroll it. And in fact, we have this explore function. I think recently Guillaume, my coworker who has implemented this grammar support, has renamed it to literally unroll. So if you unroll this up to 3, then you'll see, okay, so now I have pipelines of length 3 that have 2 transformers followed by 1 estimator. But you can actually unroll this as far as you are patient enough to wait for. And then the nice thing is after unrolling, the search space that you have will just out of the box work with any of our backends, modulo computational performance.
That's so cool.
Yeah.
So one thing that this then enables is, I think it's just not known which kind of grammars will work well. And so I think this is kind of an experimental test bed for the research community of trying to figure out, well, maybe this kind of simple pipeline works well, or maybe you also want to put in some merges in the graph, maybe you want to add some ensembling, and just opening all of this space up for automated search is kind of an untapped territory as far as I'm concerned.
Yeah, that's really quite neat. So anything else on the roadmap section that either you, Kiran, or Martin, you want to discuss before we move on to our Q&A section?
I think that pretty much covers our roadmap.
Yeah.
Maybe just to re-emphasize, I think the most fruitful entry point is probably new operators. But we are really happy to work with people on any of these things or additional things. I mean, that's the point of having a big community out there. You're not limited to our ideas.
Right, exactly. Yeah, and yeah, it seems like there's a really solid foundation from which to build out into all of these other exciting areas. So anyone who wants to contribute, either code or funding or other things, like, yeah, please reach out to the Lale project. So at this point, we're going to move on to our Q&A section, and we do have a couple of questions, but if you have any others that are burning inside of you, please feel free to ask them now. So for our first question, Arcady asks, can Lale be used with other libraries other than scikit-learn? For example, TensorFlow.
So I think, Kieran, you're in the best position to answer that.
Yeah, so the main point, well, the main thing we will have to do to support any other library is to create an operator for it. And we have examples of PyTorch and TensorFlow and Weka and R, like I said. So there are some operators already in Lale library. So if you look under Lale library, lale.lib, you will see there is a TensorFlow directory under that. But if you look at the operators which already exist, to enable your operator to be used with Lale, you will have to add one wrapper. And like I said earlier, there is a link to add new operators. It's very well documented, and we don't think it's a lot of work, but and that's what we will have to do.
Yeah, sounds good.
Okay, so our next question is maybe related. So do you just support scikit-learn or other Keras backends?
So I guess there's a question between AutoML for deep learning versus AutoML for the rest of machine learning. I don't want to call it traditional ML because some people start screaming when they hear that term, because it's also a fast-moving field. It's not just traditional. Anyway, so the thing is that in the deep learning space, there's neural architecture search, and there's kind of a whole sub-community of AutoML, and we are not really trying to capture that. What we are trying to do on the kind of scikit-learn style pipeline space is pipelines that also involve deep learning operators. And there are different places where those deep learning operators might come in. One is just as the last step in a pipeline. For instance, for image processing, typically you might do some rescaling or data augmentation, but then in the end you'll just throw a convolutional neural network at that. The other place where you would typically use some deep learning operator is somewhere in the middle, for instance, as an embedding. So, for instance, for text processing, in the middle you might have a deep learning based operator that encodes your text as vectors, so that then the rest of the pipeline can be in the comfort space of two-dimensional arrays of numbers.
Okay, so I have one extra question for you, just for me. So you mentioned earlier in our discussion that you kind of had a proof of concept of other languages. Are you planning on kind of broadening out, or is that mostly a proof of concept right now?
So other languages meaning R and Weka, which is of course Java based. So we have exactly one R operator, which is association rules. And we have exactly one Weka operator, which is decision trees with pruning. And the approach that we took for implementing them, it works. We can run with it. However, it's kind of brittle because it ends up being in the same operating system process. And when you have both Python and R or Java running in the same operating system process, you're likely to run into memory trouble. And so I think the better solution for that would be some kind of out of process, maybe via REST API or via via the Arrow, Apache Arrow, or something like that, which we haven't tackled yet. So I think that would be another great opportunity for community contributions, really, especially if people really care about the other languages.
Excellent. Well, thank you so much. At this point, it is now time for our world-famous rant and rave section, where we each get 15 seconds to rant or rave about a topic of our choice. Kieran, you are first up. It is your soapbox.
Okay, I'm going to go for rave instead of a rant. So I'm going to rave about my daily life, which includes a lot of nursery rhymes. And this is to really appreciate their creators, writers, musicians, and singers. In particular, there is one that brings a smile to my face every day these days during my car ride with a 2-year-old. And this is a variation of the classic Old MacDonald Had a Farm, produced by Super Simple Songs. The singer has done such a fabulous job. It's an interactive and joyful experience. And I would like to say all of you should just listen to it. It's just so beautiful.
We'll be sure to check that out. Martin, here's your soapbox.
Yeah, I'm going with a rant, and maybe I'll start with a disclaimer saying I love Python, and I really admire the various data science libraries that have been built in Python, and clearly their popularity proves that they have done a lot of things right. One thing that I wanted to rave about is the prevalence of magic strings all over them. So a lot of things that you do in these libraries, say giving a name to a layer in a neural network, or specifying a metric to an optimizer, or specifying a choice of a hyperparameter to an operator. Those are all specified as strings, and really, I mean, strings, we have moved past that in most other programming languages, and I think in Python we could too.
Excellent. Medican, take it away.
Okay, so I'm not going to be as positive this week. I'm going to go for a rant. And my rant is I am annoyed that every time I open a new Slack workspace that I get annoying notification sounds that I then have to turn off. And I only realize it when the noise happens. So I hate it. And I just wish there was like an overall app setting that I could just turn off all notifications for all workspaces, because that's the ideal, I think.
Here. This week, I'd like to both rant and rave about Duolingo. Duolingo is great for a lot of things: learning grammar, vocabulary acquisition, and helping you put down stupid mobile games that otherwise basically waste your life and bring no value to you. However, like so many agents in our lives, their primary metric is engagement. This means that Duolingo is not designed to actually help you speak conversationally in another language. Instead, it trains you to answer standardized tests that happen to be in another language. Now, don't misunderstand me. As a language lover who often struggles to have vocab stick, Duolingo is excellent for supplemental training. However, for real language acquisition, nothing beats struggling to communicate with a friend, teacher, or partner across the table from your stumbling mouth. And that's all the time that we have for today. Thanks for watching. Thanks for listening. You can find us on Twitter at Quansight AI. If you're interested in funding open source projects, including IBM Lale, you can find all of the roadmaps at quansight.com/projects. Martin and Kieran, where can people find you?
So physically, at IBM Research in a suburb of New York. And then, the repository, of course, is github.com/IBM/Lale. And also, I encourage you to pip install Lale.
Perfect. And join us again next episode, where just because you may never see the peaks of Mount Beverest doesn't mean you can't set your sights on Bokeh 2. Thank you, everybody. Bye-bye.
Thank you. Bye.
Thank you.